Good morning, good afternoon, and welcome to W.media. I'm Veronica Ariton, Business Development Manager at EMEA, and it's my pleasure to welcome everyone to the third episode of W.media CEE Europe Webinar Series. Our episode today is titled From Core to Edge, Rethinking Europe's Data Center Architecture for the AI Era. We are witnessing one of the most significant shifts in digital infrastructure in recent decades. As AI adoption accelerates, data generation expands, and demand for low latency services grows, the traditional centralized data center model is being challenged. Organizations today must rethink where compute happens, where data resides, and how infrastructure is designed to support the next generation of digital services. Today's session has been designed to help you navigate this evolving landscape. Joining us today for this exciting webinar are our distinguished industry experts and veterans, Kasia Sabinska, co-founder of Allocomp, John Booth, Technical Director at National Data Center Academy, Ellie Holbrook, Energy Analyst at Analysis, and Dia Radwan, Data and AI Solutions Engineer, Global Black Belt at Microsoft. And not the least, Romain Tranchant, founder at Stack District. Thank you all for joining us today. And now it's my pleasure to hand over to our co-host, the editor-in-chief of W.media, Deborah Gray, who will guide us throughout our session into more detail. Deborah, over to you.
Thank you so much, Veronica. In this episode of CEE and Europe Webinar Series, we will take a deep dive into the impact of AI on Europe's digital infrastructure. We will examine the burgeoning demand for low latency compute, decentralized computing, and distributed architecture. Why does Europe need edge data centers? Where are they being built? How are they being powered? All this and more in our webinar today. We will begin with a keynote address by Kasia Zabinska on market intelligence mapping Europe's evolving data center topology. This will be followed by a panel discussion on connecting the dots, building a scalable core-to-edge infrastructure strategy, where John Booth will serve as the moderator and will be joined by Kasia, Ellie, Dia, and Romain. After that, we will open the floor for audience questions. We would appreciate it if you could send us your questions in the Q&A section of the Zoom webinar, and we will curate a selection for our guests to answer. Please mention your name, designation, and organization along with your question. Also mention who you want to address the question to. You can send in your questions at any time during the webinar, and we will ask those questions at the end of the panel discussion. Now, without further ado, let's welcome our keynote speaker, Kasia Zabinska, who is the co-founder of Allocomp, an Irish technology company focused on optimized AI infrastructure. Allocomp helps organizations understand where their AI should live, whether on-premises, in co-location, in the cloud, at the edge, or across a hybrid model. The topic of the presentation is market intelligence, mapping Europe's evolving data center topology. Over to you, Kasia.
Thank you, Deborah, and good morning, everyone. Thanks for having me join the discussion. So I want to give you a very practical kind of, a few insights on what we believe would be important in the discussion of European infrastructure. The AI is changing things very quickly, but it's not only increasing the demand, it's completely changing how we look at data centers and what data centers actually are. I'm not sure, guys, if you can see my slides just yet. There we go. Right, so that's the first kind of key point that I think it's an important starting point for the discussion. Like I know, most of you are probably aware of this happening, but the numbers are absolutely crazy when you look at them. So when you look at the legacy data center, we're looking at the average of 8.4 kilowatts per rack. And that's the compute that we know, that's the compute that we've been familiar with for the last 20, 30 years. And the densities were increasing steadily. And then the AI era came up, and the densities we're talking about at the moment, 120 kilowatts per rack systems are being deployed. 600 kilowatts per rack, it's not far out in the future. So that is changing the way we think about the infrastructure. Those high densities allow much smaller footprint for the data center, but also make the all infrastructure around data centers, the cooling and power distribution, all that work much, much harder. So then the cooling demands change as well, which quite dramatically kind of, changes the conversation because like the GPUs are super efficient, more efficient than gas boilers. And pretty much all the energy that you put into a GPU comes out as heat. So that's changes the conversation here. The likes of the 600 kilowatts per rack NVIDIA Rubin Ultra cannot be air cooled. There isn't enough cold air in the world for that to be air cooled, so it has to be liquid cooled. Can we flick to the next slide? Which also creates an opportunity because the closed loop liquid cooled systems allow us to recover heat much easier. So that's what we believe is our green ticket for AI compute, reusing the heat. I actually don't like the term heat waste because the facility next door is probably paying for to heat things up, paying for gas or electricity. So reusing the heat is the green ticket that we see as one of the opportunities from the development of AI data centers. And the power constraints, can we go to the next slide, please? So I'm just going to give you one example from not far from where I'm from. Former Fiat factory, okay? Nothing was happening there for years, and then all of a sudden they are planned here to build a data center. And the reason for that is that this site is already allocated about 82 megawatts. The plans are ambitious. That's the opening number. They are hoping to increase that to 200 megawatts. But then it also changes the kind of way how we select the sites. It's mainly where can we get the energy, and then okay, what's around that? Would that be a suitable place for new data centers? Next slide, please. So what AI has kind of started as a cloud story, okay, which kind of was in line with what was there before. But at the moment, like as people are starting to play more with that, and then organizations going from playing with it to deployments, the landscape is changing. So there is, don't get me wrong, like all the AI, all the compute that we know, or the mega hyperscalers, the mega data centers are here to stay. But then also the new ones are emerging. So it could be anything from a regional cluster or university cluster that is being made available to local enterprises to on-prem. Like, so a lot of enterprises are realizing for many different reasons, from energy to sustainability to political reasons, like many organizations are moving back on-prem. So the enterprise AI it's a massive trend. But then also, and then the recent announcements from NVIDIA, it's kind of showing. I'd say it's early to call this a big emerging trend, but personally AI is growing. So the more people start playing with AI, the more of those things will be happening on laptops, workstations, or the likes of DJX Spark that is proving very popular. So I think the question kind of moves from which cloud services would be best is like where should your workload be based, and the answer isn't simple. So it's becoming more kind of clear that to be much more mixed environment for those workloads. Next slide, please. So making those decisions, like it has always been complex, but I think it's getting even more complex now. So everything needs to work together. And then some of the workloads, they'll be perfectly happy in the cloud. Some of them you would prefer for, again, various reasons, for data security, for example, you want to have them on-prem. Some of them, latency doesn't really matter, but some of them it's absolutely critical. So we just need to make sure that all those decisions are well informed, and everything needs to work together. And then go to the next slide. So I'm gonna use Ireland here as just as an example, okay, for what the constraints are, and how where are we heading. So Ireland is a small country. We've done very well with attracting a massive big data centers. At the moment, about third or quarter of heading towards third a quarter of the all electricity is used by data centers. And those are mainly hyperscalers. Okay, there are those big, massive data halls, nearly with the river flowing through them to keep them cool. No, I'm exaggerating here. It's not really the case in Europe, but that's the kind of model that worked well in US, and that's how we try to kind of replicate that in Europe. But the opportunity actually might come from somewhere else. Next slide, please. So if you imagine a European data center market as a lot of distributed and mixed form of infrastructure. And then if we can reuse the heat, so placing them next to the heat off-takers gives us the green tickets, because we are kind of redirecting energy from heating things to going through the compute and then heating or preheating things. So they are distributed, they are closer to users, they'll be more independent. So not trying to say that hyperscale is not the right model. I'm kind of arguing here that European opportunity could be in having the mix and moving the workloads to many different variation of a data center. So again, the data center definition changing here again, because it might be a device on your desk or a workstation. It might be the hyperscaler one, or it could be anything in between. So that's my kind of key takeaway from this presentation here, that it's not as much core versus edge. It's about having the mix and making sure that the given workload is running in the right place. Thank you.
Thank you so much for that, Kasha. And that concludes the keynote address. Let's now dive into our panel discussion. The topic is connecting the dots, building a scalable core to edge infrastructure strategy. Please welcome our moderator, John Booth, a well-known figure in the EU data center circles, primarily for his role as reviewer for the EU Code of Conduct for Data Centers Energy Efficiency Program, and his work with the Certified Energy Efficiency Data Center Award. Over to you, John.
Thank you, Deborah. So we've just heard from Kasha, who will also be joining us in the panel discussion. But let me also tell you a bit about our other speakers today. So Ellie Holbrook is an energy analyst at Semi-Analysis, an independent research firm focused on AI and semiconductor markets. Her work examines how rapidly growing AI demand is reshaping energy markets, with a particular focus on power supply for AI data centers. Dia Radwan is part of Microsoft's global Black Belt team, focused on data and AI. Over the last 20 years, he has helped organizations modernize data platforms and adopt cloud-native architecture to support the data, analytics, and AI workloads across a wide range of industries. Roman Trenchard is the founder of Stack District, a company focusing on delivering fast, flexible, and accessible retail co-location solutions. Romain has a strong foundation spanning enterprise IT workloads and the data center co-location landscape, with a focus also on innovation. So, panelists, do you agree with Kasha insofar as European AI will be a different beast to that currently being deployed in the US? Dalia?
Thank you, John. Thank you, Kasha, for the insights. Yes, I do agree, but not because the technology is fundamentally different. The constraints in Europe are different. The same foundation models and AI technology will be used globally, but here in Europe has different operating environment, energy availability, cross-border regulation, and also sovereignty requirements. And data residency concerns play a much larger role in architectural decisions. In the US, organizations often optimize primarily for scale and speed. In Europe, many organizations have to balance scale with the sovereignty, compliance, and operational model. As a result, I think Europe will produce more distributed and hybrid AI architectures rather than simply replicating large centralized deployment like in the US.
Romain?
Well, let's go back through the first thing. Everything we hear about the US generally is through the news outlets. So everything we talk about is those gigafactory data centers that are being deployed everywhere. And whilst it is true and it is happening, there is also a lot of grassroots happenings with colos and traditional players that are still out there. So let's not mistake the beast in the US for the news articles that we see. They still deploy in single-digit megawatt increments for their IT workloads, and they face exactly the same issues that we're facing in Europe, which is with the lack of power, with the constraints that we're seeing, the IT is now adapting to what is on the market from a colocation perspective rather than the other way around. So I'll leave it at that, and I'll come back on that a bit later.
Yeah, I think that's a very interesting point, actually, Romain, because, you know, we're all hearing about these multi-megawatt big data centers that are being built out in the Arizona desert or in the Permian Basin in Texas. But they're mostly for learning rather than inference. And as we know, inference needs to be closer to the actual end user. Ellie, so you work on this. So what's your take on what Kasia has kind of outlined in her keynote?
Yeah, no, I would just say that thank you very much, everyone. But I would just say that yeah, Europe can't copy the US in any any shape or form. There isn't. We have to talk about it in a completely different way. There's no political appetite for building. Well, we're seeing in the US a lot of behind the meter generation and on-site gas as companies want to energize their facilities and not waiting in interconnection queue for so long. Europe can't compete with that. I mean, I would say that those, and on the scales, 20% of European data center like capacity is like one site in the US. So yeah, the US has a choice. It can spread its compute around the country. It's more of a choice. I mean, there are some permitting issues, in terms of, the West Coast or on the East Coast, and everyone's going to Texas, but there are way more options. But in Europe, it seems to be forced, and the physics of the grid essentially leave no other option, and more of a distributed approach has to be taken. Yeah, I mean, I think it's interesting to think about the Nordics, because basically the Nordics can actually play the American game because they have the power. And now it kind of seems like everyone else across Europe is sort of fighting over the smaller slice. And yeah, that's what I would put it.
Yeah, I would tend to agree with you, actually. You can't just drop a 1 gigawatt data center facility probably anywhere in Europe. There just simply isn't the power available. Or to be more precise, there isn't power available at the moment, but there may be in the future. But, I was in Cannes recently, and I think the overriding kind of mantra was speed to market. And speed to market kind of almost assumes that the grid infrastructure is already ready to take this, but we know it's not. Germany, all of them have problems in the transmission and the distribution networks. Okay,
Yeah.
So and that's a very good segue into my next question. So we've all heard about the grid woes in almost every European country, but that actually applies across the world, I think, in Asia Pac and North and South America, and possibly Russia as well. Will this distributed cluster architecture approach that Kasia's spoken about in her keynote alleviate that problem? Ellie, and please feel free to answer that question.
I think I think, the analogy that I would use kind of here is like kind of one big team working together in one room, kind of tackling a project, but 10 small teams scattered across 10 cities can't like divide up between them. So yeah, the big training jobs are for that, and the chips need to kind of all be together in one house and talk to each other. So breaking across loads of different sites, you can't run that job. So distribution only really works for lighter tasks, and running the services, answering queries, which is conveniently what most of Europe does. It seems to be that essentially like frontier stuff is kind of a little bit out of the question at the moment.
Romain?
Well, I'd like to bring a couple of perspectives. One is the stability of the grid is down to grid operators, right? The data centers might become a positive net positive assets for grid in the future, with all of their backup systems and the ability to drop loads and so on to be able to bring stability. But the primarily role of the operator is to guarantee grid stability. And then you've got to pitch another team, which is not even the data center operators, but the AI cloud operators that are trying to find a home somewhere. And everything we see at the moment, especially through the data center market, the speed of build, the capacity to deploy and so on, is all down to those two teams trying to pull the rag into their corner. And for valid reasons, extremely valid reasons, there is demand for AI out there. There's a lot of demand out there, and we see a lot of customers coming to us and saying, can we have 20, 30, 40, 50 meg in X location? But on the other side, the operators cannot just simply say, well, we think it might work, so just have it, right? There is a lot of studies being done. There's a lot of things being done on that, on guaranteeing that the grid will continue to be stable. So when we look at the data center in the middle of all this, this is literally the push and pull that we see from both sides, and they're trying to make amends. So when we're trying to represent the data center industry as very neatly either centralized and moving to decentralized, this is not really neat. This is just a reactions to the push and pull that we're seeing on both sides.
That's an interesting point. I would somewhat disagree, though, because I think that we've already got the architecture that we should have deployed for data centers, and that's in the old telco networks. Europe, the UK alone has 6,500 telephone exchanges, a lot of which have now become redundant because they've moved to IP. So we've already got infrastructure available in towns and cities that can deliver that inference. But as you quite rightly said, smaller chunks. Kasia, bearing in mind what Romain and Ellie have said, do you still think that your distributed architecture approach is the right way?
I think it's the question is kind of like let's use what we have, okay? Like same as the former Fiat factory, okay? It's there sitting idle with a lot of power. Let's use that. The telco infrastructure that you said, and that's not even like the telco infrastructure that's being redundant, but also the new infrastructure that they all need edge servers, but loads of them are probably used only between 9 and 6. Okay, then there is a spare capacity in the evening or during nighttime, which again could be used. So I think we just need to be smart about, it's nice to build this brand new big massive data center and off you go, like knock yourself out, guys. Use what you can. But we don't have that comfort, like not here. So let's be smart about it and let's have a look. Because there are, like we have all the dots, we just have to connect them in different ways. And as Ramon said, the data centers, they don't have to be part of the problem. They could be part of the solution with the grid capacity. It's amazing how data centers are like efficient in redundancy. Like, shutting places down for an hour is unthinkable. So, that infrastructure is state of the art. Like that, there's a massive learning in that. And if we can use that for, to help with the group stability, happy days.
Okay. Right. So next question is, and this is kind of specific to the EU. Do you think that EU regulations will assist or stifle data center growth in the EU, or have we got it right, or is it going to stifle or grow? Romain can answer that question.
Yeah, I can get started on that one. Again, I believe there is no data center operator today that will say no to regulations if they can get access to power quicker. It's a give and take. And what the regulation is going to do is to be clear enough to set the mark as to what data center operators have got to do to be able to operate in their regions. What cannot happen is to have a set of regulations that, first of all, changes all the time, because that destroys all of their business models and the investments that they put in the first place, and that will stifle it. But if it is clear, it will definitely enable the growth of data centers.
Yeah. So, Ellie, your views on that, please. You're muted.
I would say that possibly regulation isn't really killing the growth so much, but I think just underinvestment of years and years and underinvestment in grid infrastructure and infrastructure more generally, power infrastructure is a bottleneck there. Because I think it's a bit unfair just to kind of blame the AI Act or something like that in these questions, because there are so many things so many moving parts. But yeah, I mean, I definitely would agree. I mean, there is definitely a kind of need to stick to a certain to a pathway, and I understand, but it's very difficult given the compute changing and the chip distribution around the world kind of changing as well. There's lots of moving parts, but trying to keep being consistent would be useful.
Kasia, have you got a view on that?
I think the sustainability angle here is important. Like, it's a race, and it's hard to kind of accept, or we need to constrain ourselves in a race because China and US are not. But I think it's super, like, no servers or no AI on the dead planet. So I think it's something that we need to be very considerate about. You see, at the moment, in the global picture, the electricity usage isn't huge, okay? But we know the direction is heading and how quickly we'll get to, that being substantial. Like Ireland is a very unique kind of example of a quarter of electricity being used by data centers, and it's not by any means representation of a global situation, but it is representation of a direction we'll be heading to. So I think it will be important to regulate that from the sustainability perspective.
And Dia, what's your thoughts on this?
I'll leave that to the experts on the panel. But regulations are in short term they introduce complexity of course, but hopefully on longer term will give more stability to invest in data centers and make things more clear.
Interesting. Okay. Well, that neatly moves on to the EN 5600 and ISO 22237 standards and the ISO IEC 30134 metrics, PUE, energy reuse, renewable energy, etc. Does the panel think that these in Europe, should they be cited into the planning and regulation process? Romain.
Well, it's a bit of a conundrum, isn't it? Because we know that the data center shape, sizes, and method of delivery are changing, and we're starting to see highly competing KPIs that are being put in data centers. So we know that if we want to do If we want to reduce water usage, we might increase the PUE and vice versa. We know that if we want to do heat reuse, that will have an impact on other areas. And the thing is, it's it's a bit like the car engines that we've seen in yesteryears. We went from bigger engines to minimum engines to right sizing, and I think the data center industry will go through the same thing. It was PUE at all cost. It went then all KPIs at all cost, and at some point we're going to be looking at what is the middle ground that we really need to hit. And I can predict also further to that. What is the middle ground? What is the right middle ground for the geographical locations in which you implement that data center? And so the definitions are super important because they enable a level playing field in terms of comparison, but they shouldn't become the end all and be all of what a data center should be. It should be looked at in context of where that data center is going to be implemented.
And I think that with the EN 5600 series, the ISO 22237, the actual standards roadmap of, developing the standard, going through the process, which can take up to 2 years, the standard being published and then being valid for another 5 years. That's 7 years in a standard cycle. And AI is just, blowing a hole through that because we know what the NVIDIA roadmap looks like. And we know that we're going from 150 kilowatt racks to 600 odd in, literally in the next 6 to 8 months. And then we've got the next generation after that, the Feynman chips, which, from all accounts is looking at 1.5 to 2 meg per rack, which, the standards are just not keeping up with the development. But I mean, you could always argue that that's the case. Ellie, have you got a view on the standards? Do you think they should be included in regulation?
I'm not really kind of in what I look at specifically, especially in EU context. But I mean, if I'm understanding correctly, I think I think that using solely PUE as a single pass or fail test is not super representative of what how the operations are actually running. For example, it only measures the building overhead and not the actual the useful work which is going on inside. So I mean, for example, you can have a fully loaded site and a half idle one can post the same PUE because it doesn't have any kind of insight or kind of visibility on what's actually going on inside. So and you can have like a super sleek liquid cooled AI facility and have a really nice PUE, but the power and water demand could be really, really, really high. So I think using more kind of more regulations in that sense could be better representative. But that's only what I've seen.
Asher, have you got a view on that?
Isn't that just yet another good example of the Gotthard's law when the measure becomes a target is not a good measure anymore? So, and as John mentioned, like the things are changing in a crazy way. I remember before the GTC 2024, we were going to, to the keynote watch party, and before the keynote, we were taking bets on. So the 120 was announced. Sorry, it must have been 2025. So or 23. Like anyway, so the 120 was announced the year before. So I think that was the keynote in 2024. So 120. So I'm sitting there and thinking, okay, so I'm just gonna double that and put something more on top just to be sure that like I don't underestimate. So I said 350, and then the 600 kilowatts was announced at an hour later. So it's completely like sometimes we think Jensen Huang is this crazy man that rocks up on the stage, says all those crazy numbers, hoping there's enough smart people in the room that will solve the problems and will make it happen. And they are the 600 kilowatts, as you said, 6-8 months away. It might be pushed, but it's what was unthinkable, a few months back. All of a sudden, it's becoming a norm. So I actually would not like to be in the shoes of the regulators trying to keep up with this, because like, or even in building data centers. Okay, so if you plan on building a data center today and you take the technology that is out there today, that's going to be something different by the time your building is up. So it's a really kind of, a crazy time to keep up with with how quickly things are changing. And then the next thing is this kind of like, I think it's a bit of a kind of romanticized image of how much compute do we actually need. And then there is this trend that I think we need to cope on as well, on kind of using AI for everything. Like it's a simple workload. An Excel spreadsheet with a good formula will do the job. You don't really need AI for that. So I think we need to cope on that front as well. That not everything needs a big shiny golden GB300. Sometimes a much smaller systems. For a lot of edge cases, like you don't need GPU at all. CPU systems will do absolutely fine. So yeah, there is optimization in literally every part, every gear of this massive system.
Yeah, that's a very good, interesting viewpoint. Right, so we're now moving on to my curveball question. None of the delegates had been prepared for this, so I want honest and open answers. And I appreciate that this could be considered to be quite a controversial question, but given the pushback from communities across the world, right? So we know that there are 78 moratoriums in the US at the moment for no data center construction. The London Climate Week is going on at the moment. I will be appearing at an event on Thursday. There is a competing event elsewhere that's getting big on AI water use. I understand that two big AI companies are coming to market in the next couple of weeks, and that would be quite interesting. But we've also got the kind of threat of quantum computing hanging in the background. So, yes, no answer. Are we in an AI bubble? And will it burst or will it slowly deflate? Romain.
I knew you'd point at me first on that one because I'm not afraid of speaking my mind on this. I used to think yes, and my mind is changing to no. I don't believe we're in a bubble. And I'm happy to explain, but you said yes, no answer, so I'll leave it there.
I'll give you a minute to explain. Go on.
The workload that we see coming and the use cases. So let me go back to one important point. If power was unlimited and we were building at the rate we wanted to, I would have said yes. But what will prevent the bubble is the simple fact that we can't build fast enough to put all the AI workloads, which means that some of the AI workloads are just not hitting the market, right? And trust me, I want to find place for all the AI. That's my leaving, but it's just not happening. And so yes, there will be some AI companies that will fail because they're not finding their markets and so on, but that will then be replaced by others. And I believe that phasing, because of the lack of power everywhere and the moratorium and the different elements that prevent AI to grow at the pace some people want it to go, will prevent that bubble from existing in the first place.
Okay, so what you're suggesting is that there are other structural issues that are preventing the build out of data centers in the format or timescale that the AI tech bros would like, and that will prevent it from being. Right, okay. Ellie, would you agree with Romain's view on that? That we've kind of already got barriers in the way to prevent a bubble?
Yeah, I mean, it depends on what you kind of mean by bubble as well, because I mean, the financing valuations obviously are sometimes completely crazy, but the demand for compute is high. And I would just push back on Romain's point about the kind of bottlenecks on. There are obviously bottlenecks on the energy side and the building side, moratoriums and whatever and whatnot, but we're seeing kind of different prefabs, modular data centers, and also an interesting thing going on with behind the meter market, whereby people were ordering turbines, and then turbines being kind of overbought, and then reserve slots kind of coming back onto the market as secondary market. So you actually can get power quite quickly if you are in the secondary turbine market in the US. But I mean, that's notwithstanding like the obvious kind of points on moratoriums and the actual gas infrastructure availability and the interconnection queues. I mean, I think it's fully dependent on where you are, if that and how that build out will occur. But Texas is very big, so maybe everything goes to Texas.
Gaia?
I agree with Roman and Ellie, and I think it's not a bubble by per se, but it's more into a hype and is more reflecting on the valuation and how people will monetize the investment and so on, and a lot of demos that looks great but fail in production and adoption inside the organizations. So it will take some time to settle in and the hype to cool down a little bit.
Kasha, I'm going to give you the final word on this.
Oh dear. Well, there's no going back. I don't think we'll ever go back to, like we know what AI is capable of, and as much as one might love it or hate it, it is changing how we work and how we live and how we communicate and how we travel and everything else. So there'll be no going back. But in saying that, maybe when you said like a bubble will deflate, maybe that's the good way to describe it. Like we absolutely need to optimize this more. Like it needs to be more join up thinking. The free kind of wild west kind of approach. That's not great. We need to go up on, and there is room for improvement. Like the from the technology side of things, like never mind the 600 kilowatts racks, but we can there are people trying to embed models onto the chip in the hardware. So we have tiny little chip that uses very little energy, but does one job only. And like you won't be able to ask it, to ask the model about, how to perform open heart surgery, but it will know where to pull the data from your database very quickly and very, energy efficiently. So, there are smart ways to optimize things. And then when you think about, okay, that might be a little random, but like the F1 cars are 1.6 liters, okay? And imagine the horsepower you get out of them. So I think there is room for improvement in data centers. We will squeeze more out of the hardware, we'll squeeze more out of data centers and make them more efficient for sure.
Very good. Have I got time for one more extra curveball question? Yeah, excellent. Thanks, Deborah. Right, so one of our questions, and this is something that I was going to talk about, but didn't put it in. ICT as a utility. Okay, so the three big elements for regulated businesses: power, gas, water. But ICT has, in general, so not just AI, but all sorts of IT, all of that. If we get an outage anywhere, I mean, we had that outage in September last year, which took out literally hundreds of other allied sites and caused loads of chaos. Is there a case for saying actually ICT in general should be considered to be utility and therefore become a regulated business? Romain.
I love the fact that you point at me every time you've got a curveball question, but I'll take it. Okay, utility themselves don't prevent outages. When we've seen that in the past, right? So if the point is to prevent outages, the fact that it becomes a regulated utility, I think is not the way to go. Do I believe regulations might be a way forward? It might be in some cases, especially when we're talking about the infrastructure parts. The thing is the size and shape of IT infrastructure is so different depending on all the use cases and all the different aspects of what we do with it, that just a definition of considering that a utility for me, I've got a trouble with. That is very difficult to just say ICT in general is a utility, because there are so many different ways of going about it.
But you could make that argument for power, water, and gas as well. So depending on your need for power, different power for residential, but huge power for production facilities, workshops, warehouses, factories, etc. The same with gas, the same with water. So they managed to regulate all of those businesses, which have the same type of differences between small users and big users. Right, Ellie.
Yeah.
I would say that kind of it's already starting to happen sort of informally in some parts of the EU, from the power side of things, like being kind of forced into utility obligations. Like I think Germany and Ireland requirement to kind of bring your own generation in terms of handing capacity back to the grid, and they're kind of being already treated like grid assets, but don't have the kind of protection of critical services like hospitals and whatnot. So I think that's kind of an interesting trend to observe. But yeah, I mean, the only thing I would say is that, once you start regulating things and kind of putting everyone under the same kind of guidance and rules across a whole, lots of different countries, it could slow things down, and the industry moves pretty fast to lock in rule books early on. So
it would do if it had access to power, but we don't have access to power.
Yeah.
I would see that
Okay, Kasia, have you got?
Look, if you look from the user perspective, and I'm thinking kind of, the end user. So I'm actually waiting for the moment when digital infrastructure will be said in the same breath in one sentence with water, roads, electricity, and everything else, because it's part of our lives at the moment, and that's how we operate. If I'd say it would be, the lack of digital services we use would be, very upsetting, as lack of water is, even if it's out for a few hours. So I think there is, it's kind of inevitable to look at digital infrastructure this way anymore, which again still happens. People will list them and then they will somehow miss the digital. But yeah, I think that's the direction we're heading to. It's becoming something that we are just so accustomed to that, yeah, it's part of the infrastructures, the whole set of infrastructure in the very broad meaning.
Okay, and finally, there on this topic, utility or not?
I think this is around the resiliency requirements, and resiliency requirements is not a new thing, and we can see today with the providers for ICT, as you mentioned, is providing SLAs, but not yet into the regulation part. But SLAs sometimes can be strong and harsh if something happen against the provider, or in any contract personally that we sign with the electricity provider or water provider is not in our favor as citizens. It's in protecting the provider. So businesses rely on ICT, rely on internet connectivity, and so it needs to be regulated somehow. And each organization should look at what they are signing for and what this provider is giving to them, so they can have freedom to move between providers and have better latency, because this is create competition and this is good for society at the end of the day.
Thank you. Right, well, I think that was a very interesting discussion. We've covered utilities, we've covered the future direction, we've covered hyperscale, edge, utility, we've looked at the regulations, and we've looked at the standards and the metrics. For what it's worth, I tend to agree with Kasia. I do think we'll have a more mixed approach. There will be some hyperscalers and there'll be a lot of edge, and I think the edge side of stuff will be directed via regulation, via planning permission. The UK government is currently going through its national planning policy statement processes that is likely to request that data center operators are using a lot of renewable energy, and they're feeding their waste heat back into district heating systems or other types of low heat uses, such as breweries and all the stuff that Kasia mentioned in her keynote. So thank you very much for a very healthy and robust debate. And I'll hand back to Deborah. You're muted, Deborah.
Thank you so much, John. That brings us to the end of the panel discussion, and now we are opening the floor for a live Q&A. You've been sending us your questions in the chat box, and we have curated a selection for our guests. The first one comes from Peter Hannaford. How do you provide sub 10 millisecond sovereign AI inference across Europe while maintaining resilience and avoiding the cost of duplicating infrastructure in multiple locations?
So I think Daya answered that in chat, but
yeah, we'd like Daya to answer that live, please.
Yeah, there are a couple of not every single workload will have the 10 sub 10 milliseconds requirements, and this goes along the line that Kasia mentioned that we will have, and also John mentioned that the training doesn't need all of this low latency, and inference could use that. So parts of the workload could require this small 10 milliseconds, and there are some workloads that are being deployed with some organizations today that is giving that, because the more that you go with the latency, the more that you feel that it's not instant, it's not real time. And we have a lot of workloads that needs that, like in a critical situation, banking transactions, and so on. So this requirement is there. The challenge is how we can take that to sovereign and make sure that data stays where it should be to abide the regulations.
Romain, I mean, your work in your life is basically identifying suitable locations for IT loads. So you obviously analyze the fiber connectivity, but I think,
well,
yeah.
So let me go back to a couple of points there, right? Because what has been remarkable is the type of contracts we used to see for a sub 200 kilowatt contract is now the same type of mechanics for a sub 5 megawatt contract. And I'm not saying that lighthearted. We used to see 3-year contracts, maybe on renewal 3+2 for sub 200 kilowatts. And now we've got people who come to us and say, I want you to find 5 megawatt for 3-year contracts anywhere in Europe, anywhere in the US, anywhere in the world. And so whilst I agree that there will be some sub 10 millisecond requirements, right now, that requirements of sub 10 milliseconds has gone down the list. It used to be up there, the network, the connectivity, and so on was up there, but has been overpassed by other types of parameters. First of all, the geography has widened a lot, right? And nobody comes to us now with a country in Europe. They come with anywhere in Europe, but maybe a couple of locations. And then that network is now almost like bottom of the list, right? And this is weird. I mean, for somebody like me who comes from the IT world, connectivity is everything. If you haven't got the connectivity to go with your applications, it's not it wouldn't be conceivable. But now that has gone down the list. So yes, there is applications for sub 10 milliseconds. Yes, we'll start seeing distributed IT and containerized solutions or prefab and retrofits happening inside cities and in different places. But right now, most of what we see is just like away from that into give us anything you can, anywhere you can. We'll figure out the rest later.
Okay. Deborah? I think Deborah's frozen. Oh, no, she hasn't.
I seem to have lost the connection for a bit. Can we move on to the next question?
Right. So I think we covered this in the panel actually. So AI will become a utility like power, water, etc. Do we agree? Do we agree?
AI,
Yes.
yes. ICT and AI, very different things. So
Okay.
AI, e-tokens and so on, yes.
Yeah.
ICT, no.
It's effectively a cloud product, isn't it? It just happens to be,
Mhm.
it's going to be that type of thing. You use it as you need it, and you like, okay, fine. Um, Michael Dell
Can you?
predicts that 75% of the enterprise workloads will take at the edge. I think we've covered that in the, and that's where the data is, that's where the work is done and where the humans are. And so, yeah, I think we've covered the very low latency. I think the current top end digital connection you can get from most carriers is about 100 gigabit. So I think that the latency piece has kind of disappeared. Um, but Peter then goes on to say, he says that he understands that Microsoft may have a different view. So do you have a different view on that, dear?
I think that was a response to my answer in text.
Oh, do you want me to cover the dismissed one, Deborah?
No, I have a few other questions that we've been getting. I
Okay.
was wondering, our show, we focus a lot on CEE, that is Central and Eastern Europe as well. And I was wondering what kind of trends have you observed vis-a-vis edge deployments in these areas?
I personally don't know the area very well. I do think there's probably suffering from legacy telco infrastructure networks from the former Soviet Union, etc. So those countries are still somewhat developing their fiber, although places like Albania have got fiber networks that crisscross the country, which was one of the first things they did. Romain, have you got anything? Do you do any work in those kind of Central European countries?
Yeah, we do, but it's the same problem as everywhere. This is more a question of is the power and the data center available? Let me add something that we haven't touched on as well. There is a whole supply chain issue, this a supply chain and commercial or investment issue that's taking place all across the market. If we're going to buy for 100 million worth of GPUs, we don't want to delay by 2 months when they can start being utilized. And those GPUs, you get put in a queue for being able to buy them. And when the buyer says, okay, now, when the seller says, now we're going to allocate GPUs, well, the clock is ticking, right? And so what we tend to see is, and this has always been the same, the lower levels of the infrastructure are moving slower. Building a data center is a 2-year cycle. Building the white space is a 1-year cycle. Then putting the IT inside it is a 3-month cycle. And the problem that we see is that not only people are coming to us with we want 10 megawatts, but we want it in 2 months' time when my GPUs are being made available. And so it's no longer a question of like where in Europe is it available? Is it Eastern or Western? And we're working with Eastern European partners. And typically what's going on, it's more a question of like, have you got a power and is it ready now? And so again, what those countries have got to do is attract investors that will actually put the money up front to be able to get you to a point that you can actually match with the requirements of whoever brings the IT equipment. And this is the trickiest part, right? We can find for 27 and 28, but we can't find for 26. All the requests I've got on my table today are for 26.
Yeah.
Okay.
I can probably help with that, Romain.
Good.
One more question. This has to do with power because that's something we've been discussing rather passionately here. How do you feel about small modular reactors for edge data centers? Is it practical or is it better to use something as expensive as nuclear technology only for the bigger deployments?
Oh, this is very much in our wheelhouse. So we have a very good friend of the academy who is a nuclear expert. He actually assisted in the development of the Chernobyl dome shield over the Chernobyl reactor, and he's working very hard behind the scenes in the UK and probably globally as well about getting the SMR designs regulatory approved by the Office of Nuclear Regulation and the equivalent in the States. we know that the reactors work, so it's really much a regulatory thing. But the problem I think we have is that it's the supply chain, right? So they've done a lot of prototype stuff, but there isn't the facilities yet to manufacture SMRs at scale and then to deploy them into various locations. And I think the whole SMR debate has really come about from American naval engineers that have left the American Navy and have gone into data centers and said, "Oh, you guys need power." Well, we had 50 megawatt nuclear reactors in a tube that was going under the water. What they always forget, I think, is that they had 80 technicians making sure that reactor was working properly. And I can't see data center operators employing 80 people per site to manage an SMR. So, and to be honest, is it in their Venn diagram? I think what they will do is enter into PPA agreements with nuclear providers that will build and maintain that facility in a location very, very close to the data center environment. But I can't see them personally being deployed on data center sites. I think it's quite interesting that companies like Microsoft and Google, etc., are investigating it. And I believe, Dio, you've got don't you have a nuclear expert within Microsoft that's exploring this?
There was some news that on Microsoft and Amazon getting the some interest in nuclear area. So this is this happened in the US, yes.
Yeah.
Okay. Finally, just a little bit of crystal ball gazing. We like to ask our experts, how do you see the edge data center landscape evolving across Europe over the next 5 years? What do you foresee?
Romain, I think you're a bit closer because you know what the investment plans are for some of the data center co-location companies. From my point, I'll let Romain answer that, and then I'll come in with my comment in a minute.
I think we're going to see a couple of things. First of all, there was a couple of comments on use whatever you've got now. And I think this is pretty much the next 12 to 24 months. There is a big EU plan on EU AI factories that's going to come to fruition as well. So that's going to deliver quite a lot of capacity for AI data centers. And then there is a substantial amount of investment going in from private companies to continue expanding their data center growth. I think what we need to remember as well is that AI comes on top of every other workloads that continue to grow as well, right? So traditional cloud continues to expand. The AI comes on top of it. And I don't believe that's a 5-year horizon, but we were talking about quantum as well. That's going to start looming, completing the picture of what IT can do. So if I have to project 5 years, and again, I'm always very careful about what I'm saying because I know somebody in 5 years' time will say, "You said in 5 years' time this will happen," but I'll say it anyway. I think we're going to continue growing. I think so growing in a way that large-scale data centers will catch up because this is what the 5-year horizon is telling us. So we're going to see large-scale data centers being implemented. I think there will be far better integration with communities around them. This is a major topic, not just from the data center industry, but all the adjacent industries as well. There will be far more cross investments going from data centers across to heat reuse, across to the grid, across to power generation. So that's going to be another area. So what we tend to see is, and this is the change, the mechanical change that's happening, is that data centers were considered just a real estate play, just like any other that would generate cash. And we're now going into data centers as an institution within the landscape of a country, right? And that for me is where the 5 years is going to be. Yes, technically they're going to be the same. Power resiliency, cooling, safety, security, all of that's going to look the same. But the look and feel and the way we're going to talk about data centers are going to be very, very different.
Kasha, I mean, you effectively in your roadmap, you've laid out the path for 5 years, haven't you?
Just the balance. So like whatever Ramon said, yes, it's here to stay. But I think as people start experimenting with it more, and then like a year or two ago, AI developer was this kind of job, like yeah, the big brain somewhere, somebody doing something. Which now, everyday Joe is trying to think like, how can I do my own LLM? Can I like, So I think there'll be a massive movement to kind of and it might not fall into the classic, edge definition, but personal AI systems and smaller kind of desk side systems.
And Ellie, because I think you've probably got the better handle on this in terms of power. It's all very well mapping out this 5-year roadmap. As Romain says, it needs to be more integrated, but actually that's really 100% dependent on how quickly the grid reinforcement and upgrades, which, to be fair, are long overdue in very much most European countries and probably the States as well. Would you agree with that? And you're on mute, by the way.
Yeah. I would agree with that. I think that puts the first order of kind of constraining the build out globally. But I think something which we haven't mentioned is workforce, and I think that's going to be increasingly an issue. I mean, it's an issue in the US when it comes to building a facility in the middle of nowhere, and kind of asking a lot of people to go over there and be there for a period of time building it, and then obviously once it's operational, there's still staff on the ground. And this might just be this. I think this is a global problem, like in terms of the shortage of engineers generally. And I think that could be something which we're already starting to see this as an issue, but I think this could be in the next couple of years more of an issue. So yeah, and talent is also unevenly distributed as well. So we're seeing, it means that things have to, people have to move around, which is not always what people want to do.
I mean, we are the National Data Center Academy, and it's our remit to try and train these digital technicians for the future. But I actually think that's probably worthy of another webinar at some point in the future. How do we address the talent gap and the skills crisis? So coming back to the actual original question, I think that the current operators of data center facilities, and I include the big tech 7 plus all the co-location operators, they know who their customers are. They're getting requests daily for infrastructure, megawatts, etc. So they know who their customers are and they know where they're going to be built. I think personally, and looking back through the UK at the moment, there is a lot of very speculative data center projects being announced almost daily, 300 megawatts here, 500 megawatts there, blah, 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 in all sorts of places. And they're primarily using gas as an interim before the grid catches up. I think those people might get burnt because I think that to come back. So if anybody says to me, I want to build a data center, I ask them 2 questions. 1, have you ever built a data center before? If it's no, I say, okay, thanks. You probably need to speak to a few more people to basically build up your team, because data center construction is not easy. They are very complex technical buildings and you need to get it right from day one. And the second question I ask them is, if you do know how to build data centers, have you selected an anchor tenant, or do you have an anchor tenant for your facility? If that answer's no, then I treat that as being an entirely speculative build. And they are literally investing billions of pounds, billions of dollars, billions of yen in a project. And they're hoping that the existing 7 or the co-location guys aren't being able to build quickly enough, and that somebody will scoop in and buy their project. And we've already had examples of that in the UK, the big data center in South Mims, that was a purely speculative build, and then Equinix went in and bought it up. So if you want my opinion, I think that a lot of people will get their fingers burnt because they don't really have the contacts within the ecosystem to actually sell the facility once they've built it. I think they're going to face the labor shortages, as Ellie just described. I think when they go into the supply chain, they're going to find that most of the production of most of the capital plant items is already pre-allocated to the big seven and the co-location companies. And then they've got the hurdles of planning permission and regulations to go through. And you know, some of our contacts and clients have been building data centers for a long time, and they know these routes through how to navigate the minefield. Some of the newer speculative projects, you know, they pop up everywhere. I don't think they've got the actual credibility to do that. That's just my opinion. You've got your opinion. We can clash and discuss over a beer at an event.
That sounds like a plan. Now over to Veronica to conclude the webinar.
Thank you. They were really interesting, you know, points and discussions. And it's amazing that we brought also, let's say, the challenges, and we had like a sort of like landscape for what's coming next. So definitely, if today's discussion has shown us anything, is that the future of AI infrastructure, it's not a place, it's a connected system. And the organizations that master power, placement, and the orchestration will define the next decade of the digital growth. Europe's opportunity is not to replicate another model, but actually to create a uniquely European AI infrastructure, distributed, sovereign, energy-aware, and built for the realities of the AI era. As we conclude today, I sincerely thank you for all of your input, and for all the distinguished speakers as well for the valuable insights and for joining our conversation. Thank you, Kasia. Thank you, Romain. Thank you, Dia. Thank you, Ellie, as well. I really love the fact that we were able to bring, you know, all the angles in terms of energy power, in terms of the compute, in terms of, you know, the cloud infrastructure as well, and where we are headed. And definitely networking and connections are also a primary thing at w.media. So let's expand this conversation further as well into Europe. Thank you.
And with that, it's a wrap. We truly appreciate your time and participation, and we look forward to expanding on our conversations and initiatives. Meanwhile, please feel free to follow us on our LinkedIn page and stay up to date on our upcoming events, webinars, podcasts, and conferences. Also remember, the next issue of w.media's Cloud and Data Center magazines drops in July. Until then, from now, our entire team at w.media, bye for now, and we will see you soon. Thank you so much for joining us.
Thank you, everyone.
Thank you.
Thanks.